Okay, so now, now we have gas. Now we have gas and we are cooking. So, what I was just leaving off at this kind of description of what a file is. Now, a file typically, people who use the ubiquitous ubiquitous charcuterie. I'm not sure what charcuterie is. Charcuterie. Yeah. So, a file that, typically in, what people think of when they think of a file is some kind of storage, like a file that is storage on a hard drive or something. And that's not really what a file is. A file is kind of a system object that you can open, close, read or write. You can delete it sometimes. You can move your files around. They're just a system object thing, kind of a thing on the system. So people, there's been this mad rush to Linux. Linux is really, I think Linux is going to be the next big thing. I really do. Now, what a file is. So like, you've got these file system listing all these files, directories, files, but there's also the proc file system, and these are all files, but they're like synthetic files. They like these numbered directories. They're kind of a directory about those processes. So the processes, like one, I think is probably init. That's kind of the first process that gets started up. I don't know. These are all just like not storage files. They're not on the hard drive. They're generated on the fly. So like you've got this proc CPU info file that's information about the CPUs. Tells you all these scary bugs and stuff. Flags, like stuff that the CPU supports, like little extras that speed up stuff. I don't know, like all kinds of stuff. Tells you how fast the CPU runs. There's I don't know what this is. Kind of just looking around now. Some information about the memory. I've got 16 gigabytes of memory. Formidable. So that's really, you know, I think as someone said, no one will ever need more than 30 seconds of memory, with a scroll bar and stuff. So, what's that? All kinds of stuff. There's also the sysfs file system. Kind of another synthetic file system like that, like proc. There's also this SHM file system. That's storage, but it's in RAM. It's a synthetic file system that just stores stuff in RAM. But it's not. It's just a file. Same thing. You just store files there, but they just go in RAM. So let's see. It's kind of. I'm not sure. I really have to work on my presentation, I guess. Like, I'm not sure what I would want to show you. We can do this cat pipeline that puts a bunch of cat stuff into cat. Bunch of cats chained together. How many cats? 8 cats. So, there's also cat clock. This is really, kind of, an iconic, this is really, pretty definitive of Plan 9. This cat clock, it doesn't have to do with the cat program. This is a different cat clock program. It's just a clock. It's just a graphical cat clock program. That's really kind of iconic of the Plan 9. It's just a traditional cat clock program that you, I don't know, it's pretty symbolic of Plan 9. So I think, it's not like a joke. It's like a meme. It's a program. This cat clock program. I think it really was like a Unix thing. One of the earliest graphical cat clock programs. It's not really groundbreaking in any way. It does use polygon drawing. It draws these polygons for the cat. It's just kind of an included utility that's just kind of like the definitive kind of Plan 9 program. So, now, this modular software design, and I'm going to have to keep an eye on the time. I gotta go somewhere. But the modular software design is where you have all these simple little programs that do one thing and do it well, like grep. Grep is kind of a search program. It so like if you grep just grep hello, it does the same thing as cat, except it only copies something through from standard input to standard output if the regular expression is found. So there is no spoon does not put anything out. But if you say hello world, it does put it out because it includes the hello. It just found that line has hello in it, so it copied it through. So like grep is just like a Lego that filters through the stuff that it finds. Sed is the stream editor. It does all kinds of stuff really. It's often like what everyone uses it for is search and replace. So like it searches and replaces for stuff. So hello world. Huh. I forgot to do this. It needs this -u option so that it'll do it, not wait for it to be closed to do its thing. So you see, like, it just does the same thing as cat, except it replaces search with replace. And those are regular expressions that, I just typed words, same as grep, where I grep for hello. But those can be more complicated regular expressions. And I'm sure there's a man page about regular expressions. Now, regular expressions really can differ quite a bit from one implementation to the next. They aren't that standardized. There's, all kinds of different variations of regular expression pattern matching. So I guess Plan 9 has the prod file system too. Not as much stuff in there. Plan 9 is really a lot more minimalist. But for example, you could grab find the grep process. Huh. I don't know. Can't find it. I guess, it just doesn't start up before the process listing. That was kind of a literary reference, I guess, somewhere or other. Oh, I don't feel so good. I gotta figure out, I don't know, all this stuff, it's really, interesting minimalist, software design, modular, very modular, everything is a file, programs are, very simple, interoperable, filters on text streams. Although, the audio is kind of a text stream too, like binary text stream, something. And the audio, I think, doesn't work right now. For some reason, I can't, type. Yeah, see? Resource busy. I wonder what's using it up. Must be this, something to figure out, I guess. But, that's just as well. I don't know, there are all these, little games. Like Cat Clock, that's kind of a system game. So oh no. Why didn't it work? There we go. So, Doom, it's got Doom, this is gonna be really tough. Put it on the nightmare mode. Oh, you fucker! Damn it, you killed me. I didn't know what I was doing. So, that's kind of the main, oh, let's see here. So, what, let's see here. The main thing that I would suggest is to read the documentation. If you're making something, be sure to write good documentation. could, readable code, readable documentation. The code can be the documentation sometimes. Good, concise, readable code is good documentation. If the code is readable, it is the documentation. So I don't know what to show you. These are the way that drivers work on Plane 9. They are 9p servers too. So everything's a 9p server. It doesn't really matter if it's in the kernel or in user space. Plane 9 is a 9p multiplexer, so 9p is a little hard to describe too. It's a file system protocol. So like 9p, everything is a file, and the files are all represented, or the file system protocol is 9p, and it is a byte stream protocol. So this is the introduction to the Plane 9 phone. 9 server file systems processes. You could read this manual page. It's a pretty simple, just like protocol for file systems, and they're not necessarily storage. So everything is a file. So I think, let's see. So like this is some files for this little clock program here. So the label is clock. You can change that. I won't, but these files are all part of these particular files are served by the window manager, which is called Rio. But everything can be accessed as a file. So like this window file is the graphical data of the window, so I can just page is an image viewer, so I can just page /dev/wsys/8/window, and that's what's in the window. So that's how you take a screenshot and stuff. There's these programs that convert stuff. So like there's a Plan 9 image format. There's and that's got a name page too. I think, let's see, maybe that's not the right name page. Image format that's not really used, it's, not used outside Plan 9, but JPEGs, everyone knows what a JPEG is. So you can use this 2JPEG program to convert like the Plan 9 image format to JPEG format, and then you could save it somewhere. So now I've got this file, and that is a storage file. That's clock.jpg, and that's like a screenshot of this clock window. So it's kind of just an interesting thing to study how it's all put together. Kind of an interesting design philosophy for for using a computer. So I don't know. I guess I'll try to think of some interesting things to show. It's always kind of difficult to explain why this is interesting. Like, it's not it's certainly not glitzy. It doesn't look cool. Like I'm not sure. Like it's not it doesn't have transparent windows and stuff. It could. Why not? That was something I thought would be kind of neat if these windows had alpha transparency. But that's not what's interesting about Plan 9. What's interesting about Plan 9 is that it's just a 9p multiplexer. It's really an interesting thing to learn about. It's really kind of an example of how a system could be created with this Unix philosophy. The Unix philosophy of modular software development means that all of these little programs do one thing and do it well. So the other day, for example, I wrote this flip program. There's a flip software package for flipping text. So kind of was it trying to impress upon this guy that you could just have like a text filter, like a flip Unix program that just flip text. That's all it does. So this flip, you know, he didn't, you know, I don't know. That's kind of it's from a more monolithic software development model. This just flips text as a simple flip filter. It's just, you know, kind of, you know, it filters all the text to be upside down. It just flips the text. So that's, you know, really kind of silly. It is a silly program. But that's, you know, that's how things would be done on in the Unix philosophy of software development. That if you wanted the text to be upside down, you would just have one, you know, this is, you know, a very, you know, a pretty short program. You know, it's just got this table of upside down letters, and then a couple, you know, a function to flip the what Plan 9 calls runes. They're characters, Unicode characters. And that's all it does. It just flips the text upside down. And then to use it, you would compose it with other parts of the system. So you know, you've got this volume, or that didn't work. Let's see, this drivers file that's a list of the, you know, various drivers. Now, if you flip that file, then they're all upside down. So it's all just about composability. You know, these simple little programs that do one thing, and then you put them together like Legos to compose them into more functionality that does other things. So like if I wanted to chat upside down, I would compose the flip program with a chat program, and then I could chat upside down, something like that. What else? Other things that I would want to show you. Well, that's about it. Plus I gotta go, so I don't know. I wouldn't say, this is a really interesting example to explore of minimalist modular software development, a software development environment. Kinda, it's not intuitive. It's not like, just easy to use as soon as you open it. But if you read the documentation, it's, a really interesting, an interesting thing to learn about, and hopefully, some of these concepts could be applied to software development. It's really just an interesting thing to explore. It could be, it's just a good research platform for tinkering and learning about the Unix philosophy. So I hope you enjoyed that. I really gotta go, but I appreciate